My dear students, good morning. Welcome to mathematics class. In our last class, we discussed about basics of logarithm. To continue that chapter, now we are going to our next topic, that is laws of logarithm or the properties of logarithm. Today our topic is laws of logarithm. Before going to learn laws of logarithm, just once to recall what we have learned in our last class, that is the only definition. That is, if a power x is equal to n, then x is equal to logarithm of n to the base a. This definition is so important in learning these laws. Come to the first law of the logarithm. Logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. This is the first law of logarithm. Now we are going to prove this property. I am going to prove this one. Look at blackboard. Observe what I am writing. To prove this formula, first of all, let us take, let a power x is equal to m, and also a power y is equal to n. Take these two, a power x is equal to m and a power y is equal to n. Now change these two relations as logarithms. Already you learned in last class. If a power x is equal to n, then x is equal to logarithm of n to the base a. Using that definition, you can write it as x is equal to logarithm of m to the base a. In the same way, the second relation also can be written as y is equal to logarithm of n to the base a. Okay, understand? Just first of all, I have taken a power x is equal to m and a power y is equal to n. Just I converted them as logarithms. Now come back. Now we take a power x into a power y. Consider this product. Take this product, a power x into a power y. Actually, what is a power x? M. So write m into, what is a power y? N. Write n. A power x into a power y is equal to m into n. You can simplify it. You know, from the laws of exponents, a power m into a power n is equal to a power m plus n. Using that law, you can rewrite it as a to the power of x plus y is equal to mn. Okay, now you observe this one. This is in the form of our definition, a part of our definition. A power x is equal to n. Here, a power x plus y is equal to mn. What is the exponent here? X plus y. So, try to change as a logarithm, then you will get x plus y is equal to logarithm of mn to the base a. Understand? X plus y is equal to logarithm of mn to the base a. What is x actually here? X means logarithm of m to the base a. Write it. In place of x, write logarithm of m to the base a plus, what is y? Logarithm of n to the base a. That is equal to logarithm of mn to the base a. Observe this. If you rewrite logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. What you get? This one, this property. It is proved. What is here? Logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. What do you understand from this formula? From this law? It is a product. Logarithm of a product is equal to the sum of the logarithms of its factors. Here, logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. We can extend this formula also, not only mn. For example, if it is given logarithm of m, n, p, q like this to the base a, we can extend it logarithm of m to the base a plus logarithm of n to the base a plus logarithm of p to the base a plus logarithm of q to the base a. Understand? Clear? If mn, here two factors are there, then you write it is a sum of two logarithms. Here mn pq, four factors are there, then you can write it is a sum of four logarithms. This is the first law. Okay. Next, we will go to second law of the logarithm or second property of the logarithms. The second one is logarithm of m by n to the base a is equal to logarithm of m to the base a minus logarithm of n to the base a. Now we are going to its proof. Observe carefully. As same as first one. Let us take a power x is equal to m and a power y is equal to n. You know a power x is equal to m. If you change in logarithmic form, you will get x is equal to logarithm of m to the base a. Y is equal to logarithm of n to the base a. Now find this quotient a to the power of x by a to the power of y. A to the power of x means m. A to the power of y means n. This is in the form of a to the power of m by a to the power of n. A to the power of m by a to the power of n can be written as a to the power of m minus n. That's why you will write to a to the power of x minus y. A to the power of x minus y is equal to m by n as it is. M by n as it is. Now observe this. This is in the form of exponential form. This is in the exponential form. So convert it as logarithm. It is easy. X minus y is equal to logarithm of m by n to the base a. Same. What is x? This one. Write it. What is y? This one. Write it. So we got logarithm of m to the base a minus logarithm of n to the base a is equal to logarithm of m by n to the base a. This is the second law. How you apply in problems? For example, logarithm of 15 by 7 to the base 2 is given. You can write it logarithm of 15 to the base 2 minus logarithm of 7 to the base 2. Thus, now second law is also, second property of logarithm is also proved. Go to third one. Third one. Observe this. Third one is logarithm of x to the power of n to the base a is equal to n into logarithm of x to the base a. Observe here. Here this x has some power. In the answer it will get as a product n into something. Logarithm of x power n to the base a is equal to n into logarithm of x to the base a. To prove it is very simple proof. You know, take this one. Take LHS, left hand side part. Log x power n to the base a is equal to, you can write like this. You know, x power n means x into n times. I write it. Logarithm of x into n times. Already you learned in first formula log mn is equal to log m plus log n. In the same way, log x into x like that. So you can write logarithm of x to the base a plus logarithm of x to the base a plus logarithm of x to the base a. Like this you can write n times. This is a sum of n terms. So n into log x to the base a. The third law is, or third property is, logarithm of x to the power of n to the base a is equal to n into logarithm of x to the base a. This is the third one. Come to the fourth one. Very simple one. Logarithm of a to the base a is equal to 1. It means logarithm of any number to the same base is equal to 1. We are going to prove this. You know, very simple. 5 to the power of 1 is equal to 5. If you write it as a logarithm, you will get 1 is equal to logarithm of 5 to the base 5. Already you know 17 to the power of 1. That is also 17. If you write it as a logarithm, you will get 1 is equal to logarithm of 17 to the base 17. Is as same as the above. A to the power of 1 is equal to also a. So you will get 1 is equal to logarithm of a to the base a. This is the third one. This is the third law. Third law is nothing. Logarithm of a number to the same base is equal to 1. You can write it, suppose logarithm of 25 to this base 25 is given. Its answer 1. Next, go to the last one. That is the fifth formula. That is the fifth law or fifth property of logarithms. That is logarithm of 1 to the base a is equal to 0. You know, 6 for 0 is equal to 1. 6 for 0 is equal to 1. Write it as a logarithm. 0 is equal to logarithm of 1 to the base 6. Take one more example. 10 power 0 is equal to 1. If you write it as a logarithm, you will get 0 is equal to logarithm of 10, logarithm of 1 to the base 10. A for 0 is equal to 1. You can write it as 0 is equal to logarithm of 1 to the base a. What did you observe? In these three relations, answer is 0. What? Here, log 1 to the base 6, log 1 to the base 10, logarithm of 1 to the base a. Whatever base are different. Whatever it may be base, if the logarithm of 1 is always 0, logarithm of 1 to the base a is equal to 0. So, these are the 5 laws of logarithms. The first one is, once I am reminding, the first one is logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. The second one is logarithm of m by n to the base a is equal to logarithm of m to the base a minus logarithm of n to the base a. The third one is logarithm of x power n to the base a is equal to n into logarithm of x to the base a. The fourth one is logarithm of a to the base a is equal to 1. The fifth one is logarithm of 1 to any base is equal to 0. Good. We discussed and learned what are the laws of logarithm. The important 5 laws are written here. Once you concentrate on these 5, then using these laws, we will go to do some problems. We will go to solve some problems. The first one is logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. The second one is logarithm of m by n to the base a is equal to logarithm of m to the base a minus logarithm of n to the base a. The third one is logarithm of x power n to the base a is equal to n into logarithm of x to the base a. The fourth one is logarithm of a to the base a is equal to 1. The fifth one is logarithm of 1 to the base a is equal to 0. You have to learn first these 5. Without knowing these 5 laws, we can't do anything in doing problems. So, now we are going to do some problems. The first one is expand the following logarithms using the laws. Using these laws, we have to expand these one. First one given, logarithm of 15 to the base 2. 15. You know, 15 is not a prime number. 15 can be written as a product of primes. How? 15 you can write 3 5s are. You can write logarithm of 15 as logarithm of 3 into 5 to the base 2. Now you observe, this one is, this log 3 into 5 to the base 2 is in the form of logarithm of mn to the base a. So, using this formula, you can rewrite it as logarithm of 3 to the base 2 plus logarithm of 5 to the base 2. This is nothing but expansion of this logarithm. Here, using the first law, we expanded like this. Come to the second one. Logarithm of 128 by 625. There is no base is not given. Base is not given. You know the base is 10. You can apply the second formula. What is the second law? Logarithm of m by n is equal to logarithm of m minus logarithm of n. So you can write it logarithm of 128 minus logarithm of 625 from second law. 128 again, you can write 128. 128 if you write in as a prime products, you know 128 can be written as 2 to the power of 7. How? 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, 64 2s are 128. That means we can write 128 as 2 to the power of 7. Now, in the same way, if you write 625, you will get 5 to the power of 4. Now again this comes to third law, third formula. Logarithm of 2 power 7 can be written as 7 into log 2. 7 into logarithm of 2 as same as 4 into logarithm of 5 to the base 10. What happened here? Given thing is this, we expanded like this. Logarithm of 128 by 625 can be expanded as 7 log 2 minus 4 log 5. Come to the next sum. This is logarithm of x square y cube z to the power of 4 to the base a. To the base a. So, you know, you can apply the first formula. Log x, y, z is there. You can write log x plus log y plus log z. In the same way, we can write it to logarithm of x square to the base a plus logarithm of y cube to the base a plus logarithm of z to the power of 4 to the base a. Now again, here it has some power. We can use third formula. Log x power n to the base a is equal to n into log x to the base a. So we can write it 2 into logarithm of x to the base a. Now how can write it? You know, 3 into logarithm of y to the base a plus this one. You try how log z to the power of 4 to the base a can be written as 4 into logarithm of z to the base a. In this way, using laws of logarithms, we can expand given logarithms. Now we are going to second problem. Look at it. Write the following as single logarithm. In previous problems, single logarithm given, then we expanded. Now it is sum of two logarithms are given. He asked to write them as single logarithm. You observe, it is log 2 to the base 10 plus log 5 to the base 10. You can write it, you know, log m to the base a plus log n to the base a is equal to logarithm of mn. I am writing the formula here. Logarithm of m to the base a plus logarithm of n to the base a is there. We can write it to logarithm of mn to the base a. In the same way, logarithm of 2 plus logarithm of 5 is there. We can write logarithm of 2 into 5. That is nothing but logarithm of 10. You know, base is not given. What is the base? 10. So what you will get? Logarithm of 10 to the base 10. Already you know one of the laws says logarithm of any number to the same base is equal to 1. So you can write it, its answer 1. Now come to the last sum. What is this? Logarithm of 10 plus 2 log 3 minus log 2. First of all, write logarithm of 10 as it is. 2 log 3 is there. 2 logarithm 2 can become 3 square. You know why? N log x is equal to log x power n. So you can write logarithm of 3 square. We write logarithm of 2 as it is. No change in it. Now logarithm of 10 as it is. Logarithm of 3 square become logarithm of 9. 3 into 3 9 minus logarithm of 2. You can write it log m plus log n. That is nothing but log mn. So logarithm of 10 into 9 minus logarithm of 2. That is nothing but logarithm of 90 minus logarithm of 2. Now you observe, this is in the form of logarithm of m minus logarithm of n. Logarithm of m minus logarithm of n can be written as logarithm of m by n. From that you can write logarithm of 90 by 2. 2 divides 90 45 times. So finally you got logarithm of 45 to the base 10. What happened here? This is the given equation, given expression. We write it as single logarithm. These are the sums on laws of logarithm. You take your textbook and go to logarithms and open the exercise. Do this sums from the textbook. Thank you.